Okay, today our objective is to multiply and divide rational expressions. If you will recall, the way we multiply fractions would be straight across. We will start by this really easy example. And of course, we reduce if possible. We can reduce diagonally, up and down, but never across. So I will reduce the 5 and the 15, and that will leave me a 3. I will reduce 11 and the 22, and that will give me a 2. I will reduce the z squared with a z cubed, and that will leave me a z. Now, let's see what we have left for our final answer. Remember, we have our negative, so it's going to be a negative 2 over 3z. Again, remember, we can reduce diagonally, up and down, but never across. Okay, now let's look at dividing. Let's look at an easy example of dividing. We have 28x over 25 divided by 21x cubed over 15. Well, with fractions, if you'll remember, you keep the first one as is. You change from division to multiplication and you flip. Then we do the same thing we did a minute ago. This will reduce by 5. 5 will go into 15 3 times. 5 will go into 25 5 times. 7 will go into 21 3 times. 7 will go into 28 4 times. Reduce the x with the x cubed, and that leaves you x squared. So our final answer is 4 times 3, which is 12, over 5 times 3, and that's 15, and we have our x squared. Okay, now let's look at some more problems. Remember, we still have to factor if possible. Let's look at this problem. If we have 2uv divided by 2u squared over v divided by 2v squared over u. Well, on division, if you'll remember, we flip it, so that will be times v squared over 2u squared. Flip the other division, so it will be times u over 2v squared. And remember, if it's a whole number, we put it over 1. So I'll reduce the 2's, and I have v and a v, that's v squared. I have a u, and that's u squared. Well, on top, everything canceled out. If you'll remember, that leaves you a 1. And on bottom, we have a 2. So the final answer is 1/2. Now, the next example. If we have 7x squared over 9y divided by 4x over 15y squared times 35 over 6xy, all to the negative 1. Well, I'll copy my first one down as is. If it is division, then I change it to multiplication and I flip it. And if you'll remember, if you have a fraction all to the negative 1 power, to get rid of that negative 1 power, you simply flip the fraction. So it will be 6xy over 35. Now, I will simply start reducing. 7 goes into 35 5 times. 5 goes into 15 3 times. 2 goes into 6 3 times. 2 goes into 4 2 times. 3 times 3 is 9. I have an x here and an x here. So it looks to me, my final answer would be x squared y cubed all over, sorry, I didn't see a y to reduce, so let me go back and say that answer again since I'm running out of space. Let me try to erase a little bit up here so I can write my final answer. Now, let me try it again. My final answer looks to be x squared y squared over 2. See, now this is not too bad. We're just simply following our rules. Okay, here we go. T minus 2 over t plus 3 times t squared plus 2t minus 3 all over t squared minus t minus 2. Remember, this section, and from now on, it's all about the factoring. So, the first fraction is simplified. The next fraction factors into t plus 3, t minus 1. The bottom fraction factors into t minus 2, t plus 1. And again, remember we can reduce diagonally up and down, but never, never, never across. So I reduce the t plus 3s and the t minus 2s. So my final answer is t minus 1 over t plus 1. Okay, the next example is x squared over x minus 1 times x plus 1 over x plus 2 divided by x all over x minus 1 times x plus 2. So I recopy the first two fractions because it's multiplication. I flip the last fraction because it originally was division. And then I see what I can reduce. Well, I have an x minus 1. I have an x plus 2. And I can reduce one of the x's. So the final answer is x times x plus 1. I would leave it there because if you misdistribute, then you will miss some points. But if you chose to, it would be x squared plus x. Okay, now we have 3x squared minus 8x plus 4 over 9x squared minus 4 divided by 3x squared minus 5x minus 2 over 9x squared minus 3x minus 2. Okay? Well, remember, it's all about the factoring. So I'm going to try to factor the top. And I think it's 3x minus 2 times x minus 2. The bottom, you've got to recognize, is the difference of squares. 3x minus 2, 3x plus 2. And I see immediately I can reduce the 3x minus 2's. Then it's divided by, and again I'm going to factor. I believe I factored it correctly. Oh, I see a 3x plus 1 I can reduce. Then I'm going to recopy it and change it to multiplication. And I'm going to flip it. And once I flip it, the x minus 2's cancel. So the answer should be 3x minus 2 over 3x plus 2. Final answer. And again, I'm going to say all about the factoring, guys. We got to know how to factor. Well, let's look at this example. If I have x squared minus y squared over x plus y all over x to the 4th minus y to the 4th. This is my big bar. Guys, if it's a fraction over a fraction, that is called a complex fraction. And we will get to that more later. But right now, this problem is simply x squared minus y squared over x plus y divided by x to the 4th minus y to the 4th. And if it is division, again, we flip it and we multiply. And I'm going to factor that top into x minus y times x plus y. And I've changed something. Excuse me. That should be erased. I was wondering about that 4. Excuse me. I have to erase again. And then it's x plus y over x plus y. And look, I can cancel the x plus y's. Then it's times 1, because this is over 1, over x to the 4th minus y to the 4th. Well, I have an x minus y here, and it's times 1 over, guys, it's the difference of squares. X squared minus y squared times x squared plus y squared. And again, the x minus y all squared factors again into x minus y times x plus y times x squared plus y squared. I can cancel that x minus y. So my final answer, seems like I'm saying that too much. My final answer is 1, just a minute, 1 over x plus y times x squared plus y squared.